Hey everybody, Mr. Bells again. This is for Precalc A. This is video for section 1-5. It's on inverse functions and parametrics. So first off, inverse functions, just to give you a general idea. An inverse function is a function that undoes whatever an original function does. So basically it takes it all apart from whatever you started with. I'll give you some examples when we go through that. And then parametric functions are some special kind of functions that we haven't dealt with before in any of our courses. Parametric function is basically a relationship between x and y that's based on a third variable t. And when we have these types of parametrics, then we're able to look at math in a completely different way than just a one-to-one situation with an x and y. And many of the parametrics that we'll deal with, we can match up one-to-one, and some of them we can't do it at all. Okay, so here we go. Parametrics and inverse functions. So we're going to start with just a regular function, 2x plus 3. Start pretty basic. And we're going to talk about inverses. So for instance this, if I plugged in a 4 into this function, then you know that 2 times 4 is 8, plus 3 is 11. And if I plugged in a 7, I'd get 17. I plugged in a 9, then I would get 21. Good deal. So if there's an inverse of x, and we write it f to the negative 1, there's an inverse function of x, and whatever this thing is, we'll pretend we don't know what it is. That means that if I plug in an 11, it's going to get me a 4. If I plug in a 17, it's going to get me a 7. And if I plug in a 21, it's going to get me a 9. Okay? So basically, whatever this original function does to it, the inverse function undoes. And there are 3 basic things that we can do when we're looking at inverse functions. One is that inverses, if this happens to be a graph, its inverse will be a reflection over the y equals x line. Okay? So every function that I have here will be an inverse over it. So for example, if 2, 8 is a point on the original function, then 8, 2 has to be a point on the inverse function because they have to be reflections over the y equals x line. Good deal? Now, how do I go about finding an inverse function? In class, we'll play a guessing game and try and do some things like that. But I'm going to kind of show you the math that's involved right now. First thing I'm going to do is I'm going to rewrite it as y equals 2x plus 3. So I'm going to, instead of f of x, I'm going to write a y. I'm going to take the x and the y, and I'm going to exchange their places. Good deal. So again, this is the algebra involved in how to find an inverse. How to find an inverse, if it even has one. Okay? And then I'm going to try and solve for y. So I get x minus 3 is equal to 2y. And y is equal to x minus 3 all over 2. And that's what I'll put in here, x minus 3 all over 2. Because now I can just replace y with f inverse of x. If I want to rewrite the notation like that. So let's try it. Let's try it here. So 11, plug it in. 11 minus 3 is 8. 8 divided by 2 is 4. Check, check. 17 minus 3 is 14, divided by 2 is 7. Yep, 21 minus 3 is 18, divided by 2 is 9. Check, check, and check. Then do a quick check on the graphing calculator. Clear and clear. Blow this up a little bit for you. Actually, I think it works better if it doesn't have a shadow on it. So I'm going to go ahead in y1, and I'm going to put my original function 2x plus 3, and zoom 6 this sucker. And you can see there's my line. Now this should be a reflection over y equals x. So in y2, I'm going to put x, and I'm going to make that line nice and thick. Again, I go all the way over here to the first dash, and I hit enter once. On the newer calculators, you have to go to that little sub-menu to be able to do it. And then on y3, I'm going to put my new one, x minus 3 divided by 2. And that's what a lot of you are going to do. And you're going to look at this and you're going to go, hey, wait, that's not x minus 3 over 2, is it? No. So we got to be really careful when we input these things in. This is x minus 3 over 2. So if I don't include my entire numerator in parentheses, then it's not going to give me the right stuff. So now you're going to hit graph, and there's my y equals x line, and there's my other line, and you're like, oh my gosh, it looks like it, but maybe it's not, because this angle looks smaller than that angle. So we're like, oh yeah, zoom 5. If I zoom 5, it'll give me a square window, and now it'll give me my 3 lines, and now it definitely looks like an angle bisector. And yes, that is a reflection over the y equals x line. So check, check, that is awesome. So next thing I want to show you is this. So it was this. If I plug in 4 and I get out 11, I plug in 11, this is f of x. If I plug that into the inverse of x, then I get out 4. So there's the first way to be able to show that it could be an inverse. Second way is to be able to show that it's a reflection. And then the third way, this is the one that guarantees it, and that's to show that f of f inverse, let me do better writing, f inverse of x equals x. So that's kind of like that composition of function things. And vice versa, that f inverse of f of x equals x, right? Or as we said it before, f following f inverse, right, of x. That was the other notation that we said that was close. So let me do it right now. So I'm going to take 2 x plus 3, that's f of x, right? And I'm going to shove f inverse into that. So I'm going to plug that into x minus 3 over 2. I'm going to plug f inverse into that, and that's this one right here. I'm going to take f inverse and I'm going to plug it into f of x. So you can see that this 2 kills this 2, and I get x minus 3 plus 3, and I get x. Sweet. So if I get all the way back down to x, that means that everything undid itself. And then likewise, if I take 2x plus 3 minus 3 over 2, if I take the 2x plus 3 and I substitute it in this way into that x, I get this. The parentheses have no bearing on it, so then I get 2x plus 3 minus 3 over 2. Plus 3 and minus 3 cancel, 2's cancel, and I get x that way also. So now I've showed that f inverse of x equals x and f inverse f of x equals x. Good deal. So what if I have something like this, f of x equals x minus 4 over 2x plus 5, and I'm trying to find the inverse of this thing? That's a little bit more complicated than we might have done in data A when we were talking about exponentials and logarithms and inverse functions there. What I did earlier is what we did in data A. So how do I deal with this? So same process, y equals x minus 4 over 2x plus 5, and then I switch their places, right? So x equals y minus 4 over 2y minus 5. And in the class, I'll let you try this on your own for a long time, and you'll be like, oh, this sucks, and it can't work, and it's not possible. And then I'll show you this. So we're going to multiply over here. I'm going to get x, 2xy minus 5x equals y minus 4, right? And then I'm going to move the 5x over here. I'll move the y over here. So then I got 2xy minus y equals 5x minus 4. And I'll factor out a y, and I'll get y times 2x minus 1 equals 5x minus 4. minus 4. Then I'm going to divide by 2x minus 1, and I get y equals 5x minus 4 over 2x minus 1. And then I can rewrite that as f inverse of x equals 5x minus 4 over 2x minus 1. And I'm like, hey, this is supposed to be true. This is supposed to be true that those two are inverses. So I'm going to do the easy math one first. Let's pick a number that's going to come out somewhat decently. Let's try. Oh gosh, these are not going to be pretty numbers. Let's try 3. 3 should be easy. And I say 3 should be easy because I know that's going to give me a denominator of 1 right here. So let's plug 3 into f of x and see what I get. So 3 minus 4 is negative 1, and 2 times 3 is 6 plus 5. Oh, sorry. I want to use negative 3. My bad. I want to use negative 3. So plug negative 3 into there. Actually, let's use negative 2. I apologize. I wish you could just go backwards in time and fast forward through this last 30 seconds. Choose negative 2. 2 times negative 2 is negative 4 plus 5 is 1. That's what I wanted. 1 for the denominator. And then up in the top, negative 2 minus 4 is negative 6. Negative 6 divided by 1 is negative 6. Awesome. So that means when I plug negative 6 into this thing over here, I should get negative 2. Let's try it. 5 times negative 6 is negative 30. Negative 30 minus 4 is negative 34. Yes? And then 2 times negative 6 is 12. Negative 5 times it's not looking good. 5 times, or 2 times negative 6 is negative 12, minus 1 is negative 13. And I get that. And that doesn't equal negative 2, and that's sad. That's sad. And sometimes I'm going to do this on purpose. So I want you to pause the video, and I want you to find out where my mistake was. Find out where it was in this process. Okay? Good. Yep, pause the video. Find out where it was. See what you got. Okay, so let's come back to it. So I started off with this x minus 4 over 2x plus 5. And then I wrote y minus 4 over 2y. Did you see that? Did you see that right there? I wrote it as 2y minus 5 instead of plus 5. Hopefully you caught that. If you did, yay. If not, this was a great experience in terms of that. So I'm going to fix it right here on this next page, and we're going to go from here. So here was my original one, x minus 4 over 2x plus 5, 2x plus 5. That was f of x. So I'm going to rewrite it as y equals x minus 4 over 2x plus 5, which makes this x equal to y minus 4 over 2y minus 5, which makes that 2x y minus 5x equals y minus 4 when I multiply that up to that and distribute it in. And then I move my y over here, 2x y minus y equals 5x plus 4. And then move my y out of this. Y times 2x minus 1 equals 5x plus 4. Then divide by 2x minus 1. And f inverse of that x should equal this. 5x plus 4 over 2x minus 1. That should be my inverse. So now, once again, when my original problem, I took a negative 2 and I plugged it in and I got negative 6. Now I plug negative 6 into this. 5 times negative 6 is negative 30, plus 4 is negative 26. Yep, 2 times negative 6 is negative 12. minus 1 is negative 13. That equals positive 2. Oh my gosh. Poof. Bad again. So what the heck happened? Oh my gosh, I did it again right there. I did it again. I just did it in a different spot. That makes that negative 5. $34, 13. Hey, so now at this point, this video is just to make sure that you guys understand that even I have issues too. So let's rewrite this one more time. Here we go. So 2x plus 5, so that should be 2xy plus 5x equals y minus 4. Move the y over, 2xy minus y equals negative 5x minus 4. Factor out of y is equal to 2x minus 1. Divide by 2x minus 1. And now, let me try this one more time. So negative 2 into this is 1. On the top is negative 6 is negative 6. Plug negative 6 into here. 5 times negative 6 is negative 5 times negative 6 is positive 30. Minus 4 is 26. 2 times negative 6 is negative 12. Minus 1 is negative 13. Holy crap, that was long. Negative 2 is what I get out of this. So these are my inverse functions. And I apologize for all that delay. But hopefully it was good in the fact that you know that precision, attention to detail is important. I don't know what to tell you. That was rough. Hey, here we go. Parametrics. Let's see how this goes. So parametric equation is our relationship is a relationship that gives you an x and a y based on a variable t. So we actually have three things right now. Okay, so we have the t as our input and an x and a y as our outputs based on this. So if I plug in 2 for t, and you can see my x is, I plug in 2, 2 minus 1 is 1. And my y, I have to take t squared as 2 squared is 4, plus 4 is 8, 8 minus 4 is 4. That an input of 2 gives me a coordinate value of 1, comma 4. Let's try one more, negative 3. That should give me a negative 4. And then negative 3 squared is 9. 2 times negative 3 is negative 6 minus 4. Or negative 10 and 9 is negative 1. So a negative 3 input gives me a negative 4 comma negative 1. Okay? And it's very possible sometimes to be able to do something like this. It's called eliminate a parameter. So in other words, can I write this parametric relationship as a direct relationship between x and y? So here's kind of how I do that. I take the simpler one of these two things and I solve for t, and you can see that this equation is much simpler than this equation. So I'm going to solve for t, and you can see that t is equal to x plus 1. And then I substitute this in the other equation wherever x plus 1 shows up. So y, or y1, doesn't matter. You'll see why I have the ones, the t's in just a little bit. So plug the x plus 1 in there, so I get x plus 1 squared plus 2 times x plus 1. And you're like, hey, it's compositions of functions, or stuff like the difference quotient all over again. This becomes x squared plus 2x plus 1 plus 2x plus 2 minus 4. And then y is equal to x squared, right? Plus 4x minus 3. And it's supposed to be that this would have gotten me the same things that this gotten me. So let's try it. Let's plug a 1 in, see what I get. 1 squared is 1, plus 4 is 5, 5 minus 3 is 2, and I missed my thing here. Should be a negative 1. Did you see that? I forgot to underline my 2 there. So 3 minus 4 is negative 1. It should be negative 1. So when I plug a 1 in again, 1 squared is 1, plus 4 is 5, 5 minus 1 is 4, check mark, 1 comma 4 works. Now I try negative 4, when I plug it in, negative 4 squared is 16, 4 times negative 4 is negative 16, minus 1, 16 minus 16 is 0, gives me negative 1. Check mark, negative 4 gives me negative 1. I've eliminated my parameter. Okay, so been a long day, kind of waiting for an important phone call here, so sorry about my mess ups. I'm going to try this, and we're going to cross our fingers that our parametric goes really well. So I'm going to show you how some of this stuff works on the calculator, and it's going to be weird and different, so you have to have your graphing calculator out ready. So the first thing I'm going to do is I'm going to go to my mode key, and I'm going to show you something on here, and you're going to be like, what the heck? It should be normal, float, radians, or degrees, I don't care. But right here, this fourth thing down, func par pol sc. This stands for function mode, and your calculator has been in function mode forever. That's how we have our y's and x's. We're going to move it down here to something called par, and it's not golf, it is short for parametrics. I'm going to hit enter, and now you're going to watch this. I'm going to hit y equals, and now you're going to see that it's an x1t and a y1t. It's like a totally different set of relationships. So I'm going to go ahead and put this one in. So t minus 1, watch this, I'm going to hit the x button. This is going to be freaky for you. I'm going to hit the x button right now, and you're going to see pops up a t instead of an x because it's in parametric mode. And yes, quick flashback, that means there's also a polar mode and a sequential mode that we'll get to later on in this course. So go back to my parametric mode. So t minus 1 is one of my things, and then the other one was t squared plus 2t minus 4, t squared plus 2t minus 4. And I'd like to just hit graph, and you're like, wait, that doesn't look like a parabola, does it? That's not that parabola, is it? And I can't exactly put that parabola in, but that's not there. So let's try zoom 6, and you're like, that's still not that parabola. That's just, it's messy. So maybe I go to my window and see what my window looks like, and I hit, what the bleep? I hit my window, and there's all new stuff here. Okay? So first of all, why does zoom 6 give me a window that looks like this? That's negative 10 to 10, and that's negative 10 to 10. Well, that makes sense, but what is this? And this is usually where I wait in class. I'm like, hey, what is this? And then most people realize, well, that's t max is 2 pi. Like, well, why does it do 2 pi? Well, it did 2 pi because we're in radian mode. So now I'm going to do this. I'm going to put it in degree mode. And this is something you got to keep track of as we do it. And I'm going to hit zoom 6. And it looks like the same thing. And you're like, well, what the heck does that mean? But when I hit window, now you see my Tmax is 360. Well, in degree mode, it goes from 0 to 360, or 0 to 2 pi for radians. But this little thing down here is different, okay?
So we're going to go back to radian mode. I just want you to know that it's going to be different for radians and degrees in terms of what these first three things are, even though the seconds are all the same. Okay, so here we go. Mode, radians, and zoom 6. Still not a parabola. Why is it not a parabola? Well, watch. I'm going to start my T min at 0, and my T max is going to be at 1. And watch what happens now when I hit graph. It only does a little bit. So it's only plotting the XY relationships from T being 0 to T being 1. You see that? So now I'm going to do this, my T max. I'm going to go up to T2. So I'm limiting how many points that this thing's going to plot. And when I hit graph, you can see it goes a little bit further. But it's still showing pixels here, yes? Okay. And then if I go here, I'm going to go up to 3. You can see that it actually curves kind of like that. Good deal. But what it's doing is it's plotting every 0.13 t values. So if I change this to 1, it doesn't really show up much difference. But if I change this t-step to 3, now you can see that it does a straight line. It doesn't curve anymore because it plotted this point. And let me show you y max of 30. And it plotted that point, and it connects them. Now, if I do t-step of 4, do you see that's going to jump? So what it's basically going to do, it should just put a dot on the screen because it doesn't have another value above 3. You see that when I hit graph, there's my pixel dot. Can't do it. However, if I do my T-max to 4, now we'll do a straight line from there to there. So how does this involve my parabola? Well, my point is, things are going to look not exactly like what they are based on your t-steps. So I'm going to do a t-step from -4 to 4, and I'm going to step it up by 1/10. And now watch. I get part of my parabola, but you'll see it's not symmetrical. It's not symmetrical because I'm not graphing from the left side to the right side. I'm graphing from a t value that gets me that xy coordinate to a t value that gets me that xy coordinate. So if I make this T min now -6, oh, sorry. Did you see that? I put 2 negatives in there, -6, which made it a positive. Now I get a little bit more symmetry going on, and I can see that. Okay, so that's kind of some basic stuff about this calculator and how the points work when you're plotting them in there and why they will look different. Okay, so if I change some stuff around here, let me do this as say a t cubed minus 2t plus 6, and I hit graph. What the heck? Did you see that? It gave me something that really breaks the vertical line test. It gave me 3 things. 3 points that are vertically above each other right in that location. And that's this parametric portion of it is what's going to allow us to do many, many different things as we go through here. Okay? That's the end of our video for today. Hope that was at least a good intro on the calculator. Please play around with that so that you know your calculator really well. And don't be like me on this one. Pay attention to detail as much as you can, as soon as you can on that. Thanks. Bye.